So, welcome to looking at the night sky. So, what we're going to look at in this lesson is what's involved in astronomy, and basically, astronomy is looking at science that studies things beyond Earth. So, anything that's celestial. So that could be stars, it could be planets, and anything in the universe, really. And the universe is everything that includes energy, matter, and space. So if you look at the history of the universe, and we'll talk more about this later, this is sort of like the Big Bang, and it is the Big Bang theory. And when you're looking at the Big Bang theory, all of this happened, so right up to about here, so up to that level, happened in a few seconds. Okay, and then everything else took like a million years, billion years, so 1 billion years, 5 billion years, and then 15 billion years to get to here. So basically everything from here to here and in between was a couple of seconds, and then everything from here to here, we're looking at 15 billion years. So that's kind of the time scale that we're looking at when we talk about what is happening to the universe. So very quickly, let's just look at stars, and basically stars are just big bodies that is made up of hot gas, lots of energy, and they give off light, so therefore they're luminous. And of course, the most important star to us is our sun. And if we talk about size, and we will be looking at size, the mass is 3.4 times 10 to the 5 and 1.3 times 10 to the 7 times the mass of Earth. So that's rather large. So 3.4 times 10 to the 5, oh, sorry. So 340,000 times the mass of the Earth. And of course, they look like little dots out there. And in the grand scheme of things, if you look at this diagram, this is our sun right here, that little orange. And then these are some other common stars. And in comparison to this right here, our sun, we can't even see the size of the Earth at this point. So the size of the Earth, it's smaller than that little red dot that I just placed on the screen. So that just gives you an idea of some of the sizes of the stars that exist. So after looking at stars, of course, we have to look at planets. And planets are large celestial objects traveling around stars. They do not give off light. And of course, we have the 8 planets in our solar system. So Mercury, Venus, Earth, Mars, that's your 4 terrestrial planets. And then Jupiter, Saturn, Uranus, and Neptune, and that's your 4 gaseous planets. Um, Again, looking at size, it's really easy. This is Earth right here. So this red, well, I'm coloring it in red, round ball. So let me just erase that again so you can see it. So Earth is right here, and look at the size of something like Jupiter. And remember, when we talked about it, Earth can actually fit in Jupiter's storm twice. Okay, so Earth is definitely very, very small compared to the size of Jupiter, and even Saturn, Uranus, and Neptune. Those are large as well. And then if you look right here, right under that red dot, that would be the size of Pluto, even though it's not considered a planet anymore. But now you can see why it's considered a dwarf planet, because it is so tiny. So Mercury and Mars, like what I said before, are the terrestrial planets. They have rocky surfaces. And then you have your Jupiter to Neptune, which are your gas giants. And it's mostly made up of gases and liquids. So You can see I've crossed out Pluto here, poor Pluto. But now when we look at these compared to each other, you can see how big Earth is compared to, Pluto and Mercury and Mars. Venus is a little bit smaller, but not too big in comparison. But then if we had to draw Jupiter alongside of this, it would be quite large. Moons, of course, these usually orbit planets, so it's a type of satellite that goes around the planets. Mercury and Venus do not have moons. However, Jupiter and Saturn have over 60 each. We, of course, have one, and it's quite small with regards to moon standards. So some moons are larger than Earth itself. And we will be looking at the moon and sort of looking at the different phases of the moon a little bit later, and we'll do a fun little activity with that. But here's just some showing you just some the idea of what the moon, how the moon rotates around the Earth. Galaxies, of course, these are just huge collections of gases and dust and stars and planets and everything. And of course, our galaxy is the Milky Way galaxy. And if you look at this galaxy, what you may not realize is that Earth is actually on one of these. Ours is a spiraling galaxy, and on one of these like spiraling arms, and I don't know which one from this diagram, say if it's this one here, this would be like, oh, sorry, that red dot right there, that would kind of be our sun. So considering the size of the sun and the size of the Earth to the sun, this is our sun in our big galaxy, and that's quite amazing. And these are just some pictures of all the other galaxies that exist out there. The Milky Way, like I said, it is a spiral galaxy, and it has about, this one's been formed of 14 billion years ago, and it has a big concentration of stars out there. And if you, this one, it shows actually, this is the approximate position right here of where our sun is in our whole galaxy. So that's pretty big. Our galaxy is estimated to be 100,000 light years across. And that's just one galaxy in uh, billions of others. Now, the next little bit are just some facts, and it's not necessarily things that you must know, but basically, stars, dust, gas fan out from the center of the galaxy, approximately 100,000 light years in diameter. We are located on just one of those little spiral arms, about 26,000 light years from the center of the galaxy. And so while we think, we're rotating around the sun, um, all of the objects in the galaxy are actually revolving around the galaxy center as well. So we are also rotating around in the galaxy. Basically, it's estimated 250 million years for our sun to go through one revolution around the center of the Milky Way. And our galaxy is actually just a part of a galaxy cluster that includes 30 other galaxies. And scientists have calculated there's about 400 billion stars just in our galaxy alone. So remember, the sun is just one of them, little tiny itsy bitsy one, and there's you can't even imagine how many there are that exist. The sun, and actually just one second here, basically the sun emits electromagnetic waves, and sorry that just got cut off there. So the sun emits electromagnetic waves, and that travels by the speed of light, and that's our EM radiation. Okay, and basically, let me just get rid of that for you. It's made up of different types of waves. You have radio waves, microwaves, right on down to gamma rays, and these are the ones with the lowest amount of energy, okay, right up to the ones that are have high amounts of energy and of course can cause major damage to us. So the sun's EM radiation is the Earth's original source of energy, and I would like for you, um, if we get a chance in class, I will show you these solar storms, which is pretty interesting to watch. And you could just Google solar storm, and you should be able to find it on YouTube very easily. So this is the electromagnetic spectrum right here. Like we said, you have the radio waves, very long waves, so not as high energy, right up to the gamma rays. And you can see here the wavelengths are really close together and tightly packed, and that's going to give you that higher energy. And of course, don't forget, the only amount that we can see is this visible spectrum right here, which is this little tiny portion in the middle. And if you look, it's actually this little portion right here, and that's our rainbow, of course. There is Solar Storm Part 1, Part 2, so that is something that I would highly recommend. Just go onto YouTube and search Solar Storm 2012, and you should be able to find that really easily. Now, if we look at the structure of the sun, there are some terms here that you need to know. So it's just definitions, really. It's something you can look up in your textbook. The core of the sun, that's the center, of course, that's what you get where you get your high temperature and pressure. You got the radiative zone. That's the first layer. You have your connective zone, so hotter substances rise to the photosphere and colder substances fall. And then your photosphere, this is where the temperature is about 5,500 degrees Celsius, and then you have your chromosphere and corona, and that's the inner and outer atmosphere, and this is where the temperatures get really hot, because 5,500 is not really hot when you're comparing it to 60,000 degrees. So these are just some nice pictures of the sun. This is actually Earth, this little blue dot right here. Okay, just to give you an idea of the size of Earth, just for comparison purposes, we are not that close to the sun, however. Um, and basically what this would be called a solar prominence, and this, we'll talk about these in a little bit. But so you can see here you have the core right in the center, okay, radiative zone, that's sort of this part right here, the chromosphere on the outside, and the photosphere right here, sort of this part, and then you have those solar prominences, which create, some of the solar storms and stuff like that. So the surface of the sun does rotate like the Earth. It takes about 25 days to rotate completely. And of course, there's different areas on the sun creating sunspots, so cooler areas, you have warm areas, hot areas, cooler areas, cool being a relative term, of course. You get those solar flares, so large amounts of gases and particles that are found near those sunspots. So you can see sort of right here in this area. In this area, you have the sunspot um, going on there. And then, of course, you have the solar prominences. And this is just low energy gas being ejected out through the corona of the sun. So these just, ejections of gas and stuff, which is pretty cool. And again, just, the Earth, which is pretty small comparatively. Now, of course, the sun makes amazing shows for us. We have the auroras, and basically because of solar particles colliding with matter in our atmosphere, you actually get these really, really neat auroras, the northern lights and southern lights. And basically they happen at the same time in the north and south poles, or northern hemisphere, southern hemisphere, and it's pretty amazing to see if you've ever had the opportunity to see that. And these are not photoshopped, these are with no filters. These are the actual colors of the northern lights, and it's just basically gas particles being excited um, by the solar particles and the energy that's coming in, and that's pretty amazing.